So here we are having two trees. This is the first tree, and here we are creating this tree, and this is the second tree, and here we are creating the second tree. So here we first need the node class to construct these trees. So let's create this class node, and now let's take a constructor and here pass data. Now let's set the data, and each node will be having a left and a right. So this dot left, and initially let's say it is null. This dot right is null. So we created the node, and here we are constructing the tree. At the left of the root we are adding node 2, and then at right we are adding node 3, and at the left of 2 we are adding 4 and all the other values, and similarly for this tree too. Now let's create function to check if this root 2 or tree 2 is the subtree of tree 1 or not. So here we are going to pass the tree and the subtree. Now here first we will check if the subtree is null. If it is null, then it's obviously the subtree of the tree, right? So here if it is null, then we will return true. But if the tree itself is null, if tree is null, then we will return false here. Now we are going to do the traversals. First is in order traversal. So here we are going to take two arrays or two lists. First, let's say it is first, and we are having let second. So in these lists we will be storing the in order traversals of these trees. So first is to store the in order traversal for tree, and the second is to store the traversal for the subtree. So here we are going to call in order function with tree and first. Okay, and one more call to traverse the subtree. So here we are going to pass second, as we are going to store the result in the second array for the subtree. Okay, so we will be storing the nodes of tree in first and the nodes of subtree in second. Now let's create this function in order. So function in order, and here let's pass tree, or let's say node, and the structure in which we are going to store the nodes. So if the node is empty, then we don't need to do anything, so we will return from here without doing anything. So we are going to return from here, otherwise we are going to do the stuff. So in order traversal, first we traverse the left node, and then the node itself, so node, and then the right. So to traverse the left is again left node of this node will be another tree. So here we are recursively calling in order by passing the left of the node and the structure in which we are going to store the nodes. And now the list itself, the node itself, so we are going to directly push the node in this list. We don't need any call for that. So node.data, as we are going to store only the data part. And now the right, so here again we are going to recursively call in order for the right of this current node. And let's pass the list. So this will do the stuff recursively, and we will get all the data in the first list and also in the second list. Now we are going to check if all the elements in second are present in the first or not. So here we are going to create a function list to string. So this function will convert this list and will create a string of all the elements present in this list. And let's pass the list, and then we will return the equivalent string from this list. So first let's convert this to string and then use the replace to replace commas with blank strings. So let's do this, and here blank space. So now back to check subtree function. Here we will check if this string that we're getting from first, if this includes all the elements that we have in second, that is, if this includes this second string, then actually we are going to do it in reverse. We are going to say if this does not contain the other string. If this does not contain the other string, then we are going to return false. This is because if this is false, then we won't do pre-order traversal for it. And that's why we will return directly from here, return false from here. So, but if this condition is not satisfied, if this list first contains all the elements from the second, then further we are going to do the pre-order traversal. So this was in order, and now we're gonna do the pre-order traversal. So it will be exactly same like in order. So here we are going to copy this and paste this, and we don't need them to declare, we don't need to declare them again. So, and now at the place of in order, we are going to call pre-order. Now let's create this function pre-order. And here, let's change this to pre-order. And we know that the only difference that we have is that in this pre-order traversal, the node comes first, then comes left, and then right. So let's take it at start, and then left, and then right. So now after traversing the list in pre-order, we are again going to check for the substring, right? And finally, we will return true if all conditions that we want are satisfied. So this is the implementation, and now let's call this function check subtree for these two roots or for these two trees. So here let's call check subtree, and let's pass the root 1 as a tree and root 2 as a subtree. And as you can see, the root 2 is not a subtree of root 1. We must get false. So let's console.log it, and now let's go to terminal. And let's go to recursion, and now let's run this program. Binary subtree. So we're getting false. Now let's change the input and then retry this program. So here if we change 456 to 245, which actually is a subtree of root 1 or tree 1, and here also let's change this to 2, 4, and 5, and if we try running it again here on the terminal, let's see what we get. We are again getting false. There must be something going wrong in this program. Oh, here we are taking in order, and here we forgot to change it to pre-order. So here let's change this to pre-order, and now let's run this. So this time we are getting true. And now let's try one more time. Let's change this to 1 and let's run this. So we're getting false, right? And let's make it the subtree. Let's say this is 3, 6, and 7. And now let's run this. So we're getting true. So it's working perfect now. So this is the implementation of how we can traverse the binary trees and how we can use these traversal techniques to find out if a tree is a subtree of another binary tree or not.